Now I welcome Ranjani Koduganti, who will talk on Industry 4 or Gen 4 applications for mold molding. Ranjani is, I can add that is a very active member of IPI Chennai chapter committee, and she is quite active. And she is a graduate in polymer science and rubber technology from Madras Institute of Technology, and done her post graduation in printing and packaging from the Engineering College Chennai. And she's been running the quality containers from 2013. And I now invite Rajani to share with her our presentation and her views on the way the blow molding industry is demanding from their supply. Rajani, welcome.
Yes, thank you. Good afternoon to all present here. And I thank IPI Chennai and IPI India, and of course Narayan sir of Polyene General for having given me this opportunity to talk today among all the eminent speakers present here. So I would like to talk about Industry 4.0 applications in the blow molding industry. So I'll share my screen and I'll start the PPT. Sir, it shows host disabled participant screen sharing. Can you check that?
India, you'll have to check
Yes,
the
sir.
administration.
Yeah.
Yes, sir. Now I'm able to share
Yeah.
it. Is my screen visible?
Just started. Yeah, it's visible now.
Yes, sir. So I'll start the screen. I'll start the slideshow. So I would like to talk about Industry 4.0 applications. I'm sure this term Industry 4.0 must have been heard by everyone present here, because this has been a term that is highly talked about. So this concept, or Industry 4.0, was first highlighted in Germany. And Industry 4.0 is also, otherwise we also refer to it as a smart factory or an intelligent factory. So I would first like to talk about the basic concept of what an Industry 4.0 is. So we would like to imagine, like, what if a blow molding machine can set itself up to mold a bottle by computing its own recipe and even figuring out molding parameters, including change over to a new mold. This idea, or this is ultimately the goal of what Industry 4.0 sets out to achieve. So the underlying goal of Industry 4.0 is to create intelligent machining, and through the collection of process data combined with artificial intelligence to improve production. So how exactly is this achieved? So basically all machines on the shop floor, including upstream and downstream equipment, all machines are connected to a centralized network from which data is collected on a live basis, and the live data is analyzed and sorted out. This is also achieved through use of sensors, predominantly sensors, I would say, and then other artificial intelligence systems. So what are the benefits of using or switching over to a smart factory? One thing is it helps operators keep track of failures so that we can focus on factors that prevent downtime, because unexpected downtime definitely leads to losses for any processor. So the major goal is to prevent unexpected downtime. Next is by controlling process parameters and by constantly monitoring them through live data, product quality can also be controlled. Then a greater integration of auxiliary equipment into the primary machine through use of sensors. And it also provides a global standard communication interface where all devices connected to a centralized network can talk to each other, talk to as in communicate with each other. The data can be communicated. So the components. So Industry 4.0 is also a smart factory or a connected factory. We are not going to use any bring in very new equipment. We also can use that, but it also focuses on using existing equipment, improving it, and then placing it at the heart of a network where all information can be shared. So there are six major components which are used when it comes to an Industry 4.0. One is the Internet of Things. It allows the development of newly manufactured products. Internet of Things is basically a digital connection of all physical machines or equipments. Then, of course, 3D printing has been in the development in the past few years. So it opens up new production possibilities, and even small quantities or small batches can be produced using 3D printing. Then collaborative robots or cobots. Basically, collaborative robots are or cobots are those robots which also communicate or work alongside humans and not just as industrial robots. So these robots are used for operator assistance, and they help improving productivity, safety, and efficiency. Next is augmented reality. So this also allows operators to rapidly intervene by following the procedures. So in case we can like predict upcoming failure modes, and before that failure occurs, the operator can intervene and solve that problem. Then cyber physical systems. These allow new features to be added to the physical elements or machines for process control and management. Then industrial big data. So all the data that is collected is big data. It can be evolved into smart data with the use of artificial intelligence. And this will also help in predictive maintenance. So these are the basic concepts of Industry 4.0. I'm going to talk about, definitely when we talk about Industry 4.0, the focus is on electronic systems, as in the control systems, and of course, all the features that are offered by machine manufacturers. So I would basically like to talk more about sensors, control systems, and the features or products that are offered currently. So Seidel Group, this group, they focus on providing automation solutions to the packaging industry. So they have this program called Agility 4.0. This program helps in smart manufacturing and smart production. So they've envisioned a smart blow molder who could control the entire process, including automation. And future machine operators, like the future is going to be where we strap on virtual reality glasses and follow instructions in 3D. So the Seidel Group, they offer a program called IntelliAdjust, which autonomously controls the system's performance, and we can make adjustments. It has features such as we can detect and calculate, analyze the shape of the bottle, analyze and optimize wall thicknesses, and also adjusting temperature. This information, the system provides information from the machine to the operator. So this Agility 4.0 program focuses on 5 basic pillars. So there are 5 components, which are a connected factory, a virtual factory, a smart factory, an extended factory, and a sustainable factory. So a connected factory, as we discussed before, is where all machines and all subsystems are connected to each other. So this data generated through this process can be used to optimize performance and also predict any need for maintenance. This data can also be integrated upstream to ensure material flow, and downstream to keep smooth distribution and also to prevent overstocking. Then virtual factory. So we can simulate the machine operations virtually, and through accurate simulation and testing operations in a plant before execution. So this virtual simulation also increases the likelihood of successful implementation. Next is smart factory. So as mentioned before, they use robots, cobots, and intelligent kinematics to improve performance. Also assists operators working on repetitive tasks so that operation reliability is improved over time. Then sustainable factory. Sustainability is definitely the trend and what we should look for nowadays. So production of smaller batches closer to the centers also reduces transportation. And by reducing transportation costs, we can also improve sustainability. And extended factory is also includes intra-logistics. It enables access to flexibility and asset utilization. So these are the 5 pillars that Agility 4.0 program uses. Based on these 5 components, Seidel Group offers solutions to the blow molding and packaging industry. Next, of course, Beckhoff control systems. Beckhoff provides an entire range of control systems for machine manufacturers and for machines. Apart from control systems, they also provide HMI software. So they help in getting a complete production cell. So Beckhoff systems have, these are basically 4 products that they offer. One is a TwinSafe is a solution that they offer. TwinSafe is the name of the solution. That solution helps in reducing engineering effort And it includes use of servo motors and drives of all performance classes. And apart from that, they also offer a HMI software. So this user interface, they allow the interface to be customized according to machine manufacturers and processor requirements. Apart from that, EtherCAT, it is a global standard for real-time communication, and it offers maximum performance and in integrating third-party power controllers. The Beckhoff input-output system basically uses sensors and actuators and also supports interfaces to different systems. And then the IoT bus coupler is basically an electronic component. It is used, they provide this component for the direct acquisition of digital or analog process values and help uncomplicated transmission of data to the higher systems via cloud protocol using a pre-configured access. So this is about open automation technology for blow molding machines. Beckhoff offers control components in software and also hardware for extrusion blow molding machines of all types of drive technologies. And they also offer a wide portfolio of standard operating devices for a user interface. Then they also offer technology modules. So this one is for automation and control systems. Here they offer for also motion control technology. They offer components. So for blow molding, extrusion blow molding process, the Parisian control, then control of movement of clamping unit, and then movement of mandrel are deciding factors to control product quality. So the plastic application, TwinCAD application components offered by Beckhoff provide appropriate motion control technology for this purpose. And next is about the user interface that they offer for blow molding machines, which, as I mentioned before, is called TwinCAD user human machine interface. It provides the user with a location independent visualization, as in even it does not depend on the geographical location of the user. Wherever the user is, he can access the parameters and the display system of the machine. So the process data are aggregated synchronously with the machine cycle. They use TwinCAD analytics software. So plastic processors can use this data representation to analyze and rectify quality problems and reduce productivity due to faulty functions. So these are some offerings which are offered by Beckhoff systems. Next, of course, Becom is a very known name in the machine manufacturing field. They have their own control systems, and I believe Becom control system 8.0 is currently used in their blow molding machines. So they have also introduced the concept for remote maintenance. So even for machine maintenance, they install sensors and they equip it with the interface so that the service engineers do not have to go directly to the plant for any sort of maintenance. Even the maintenance and controls is done remotely. So they also provide that the machine network for the system and the customer's other production network are separated by firewalls. So there is no mutual interference due to data transfer. And Becom also does not connect directly to the customer's network. It connects directly to the machine. Apart from that, they also provide another option in the hands of the customer, where there is a key switch on the machine that needs to be activated to enable this feature. So if the customer does not want the machine to transmit data to the Becom servers, they can just switch off the machine to prevent this. So the control is in the hands of the customer. And all components of their machines are equipped with an Ethernet interface so that if any component has an issue or is faulty, it can be accessed remotely by their support team. So next, I would like to talk about the control systems and PLCs offered by Siemens with regards to Industry 4.0. So Siemens is a very known name, and they offer improved PLCs that enable rapid diagnostics for machines. And the basic concept of Siemens PLCs is their MindSphere interface, which is a cloud-based open Internet of Things operating system. So this interface allows for a graphical display in an open cloud platform that capitalizes on remote monitoring. So remote monitoring is a key feature of Industry 4.0 that is promoted by all manufacturers and control system offerers. So this Siemens interface also enables easy linking machines and physical infrastructure to the digital world. And big data can be harnessed from any number of intelligent connected devices. And this interface and Siemens systems use predictive analytics which gives an indication of what component in a machine is heading for failure. So by analyzing and predicting which component can fail in the future, it can the fault can be rectified before the actual failure happens, and this helps prevent downtime. There's another another option or another system called digital twinning, where a digital twin, it basically refers to a model or a digital replica of a physical asset. So any machine or equipment can be digitally modeled along with its processes and systems. So this is basically digital simulation. So a dynamic real-time pulse of the machine can be done using this concept of digital twinning. So by simulating and analyzing everything digitally, we analyze the machine processes and possible failures, functionality, and upcoming failure modes. Also, this concept is also used for monitoring, and it provides prognostics of a machine's reliability, functionality, and analysis of any upcoming possible failure modes. Next, apart from this, there is a startup called Instrumental, which is offering artificial intelligence solutions for manufacturing optimization. So this startup has also recently raised funding, and they offer solutions for an entire range of industries, including the plastic industry. So they unify product data to deliver the information you need when and where you need it, so that any problem can be found and identified fast. Instrumental uses visual inspection, like they have their own manufactured camera, which is their proprietary product, and they also have their own software. So using visual inspection and other AI developed software by themselves, they monitor and identify anomalies and help prevent production line breakdown. So artificial intelligence, the solutions that they offer help discover anomalies in real time from the day one. And complete failure analysis can also be done quickly and also again remotely. It also helps in real-time monitoring and analytics for any issue. We can achieve continuous yield improvement, and we can have real-time visibility into top issues and line status for one or many factories from anywhere, and any quality issues can be detected earlier, long before the product reaches the customer line. So next, EcoAxis. So this, I'm going to talk about an Indian company that offers an IoT solution for the plastics industry. So EcoAxis is based in Pune, and they also offer IoT solutions and solutions for digitization and live monitoring and remote monitoring solutions for the plastics, even injection molding and blow molding industries. So their product is called Axis Plast 4.0. It allows customers to unlock intelligence of things by data acquisition and data analytics from the shop floor to the top floor. They offer solutions with online dashboards, reports, and analytics. So literally their solutions can be accessed using any device anywhere. We can even view our machine data on a mobile phone when we are traveling, or when we are in a distant location, or when we are remotely managing our units. So you can access any sort of data regarding the machine on a live basis, and then you can help in maintenance and all, or to analyze the data and to prevent any sort of future failures. So their system, EcoAxis system called Axis Plus, they offer a console view, then production analytics, quality analytics. So you can see live status of all machines. We can also analyze the production on quality, production in kilos, rate of production, then performance monitoring, even mold analytics can be done. Then we have online automated reports. We can customize their product to view all the information that we require on a live basis. So we can also track key performance indicators. So this is basically access to all machines on a remote basis through even using mobile phones. So they also use sensors and their own software to provide this kind of services. Next, definitely Industry 4.0. There's always upcoming industrial revolutions which come up, which is the evolution of the industry. So Industry 5.0 is also an emerging trend that is being talked about. Industry 4.0 basically focuses entirely on machine intelligence and intelligent machines. Industry 5.0 also recognizes the contribution of people. So apart from machine intelligence, it is also about human intelligence. So it refers to people working alongside robots and smart machines. It is about robots helping humans work better and faster by leveraging advanced technologies, and adds a personal human touch to the Industry 4.0. So it is basically combining the best of both worlds, best of human intelligence and robots and machine intelligence. So it is aimed at merging cognitive computing capabilities with human intelligence. So Industry 5.0, the terms that are going to be talked about is it is going to create the role of a person called as Chief Robotics Officer, who would specialize in interaction between machines and operators. It should be somebody who has extensive knowledge in the field of robotics and artificial intelligence. And regards to Industry 5.0, there's also a platform software called the Nexus Integra platform that is currently being offered. They support the transformation of a company into the next stage. It helps for the large scale management of industrial assets, allowing companies to take the leap towards digital transformation. So I'm sure in the next K 2022, Industry 5.0 trends will definitely be talked about by even machine manufacturers, processors, and I'm sure it'll be one of the themes in the next K. So this was my presentation, and I thank everyone for having given me this opportunity to talk about Industry 4.0. Thank you.
Very illuminating. Thank you so very much, ma'am.
Thank you.
Thank you, Ranjani. I think one thing we need to look at it is the ERP came, which was, everything other than the manufacturing was covered, the process of purchasing, your finance entries, your
Yes,
production entries and everything, ERP
Yes,
got into that. The Internet of Things is gone into the manufacturing per se, and hopefully we
Yes,
see that how we can improve our manufacturing both from a quality and and ultimately it's all about cost and the quality, which boils down to business. And
Yes,
hopefully
that's
this would
true.
help us to get it there and
Yes,
improve
sir.
our own quality and manufacturing. Thank you, Ranjani. I think
Thank you, sir.
questions we can collect towards the end of the day, end of the program.
Yes, sir.
I would now welcome